Okay, let's give you guys some more practice. So looking at this function here, show that this function here only has 1, 0 in this interval here. And don't forget, this function here is continuous and it's differentiable. Okay, so before you jump in and just tackle the problem, try to understand what's going on. So try sketching this graph here. So this one has an intercept of when x is small, it wants to do this straight line here. So the intercept is 1, gradient of 3. When it's big, it wants to do this here. That's like a positive quadratic. So guess your graph to look something like this. Well, it could, well, in this interval here, it could be talking about this bit here, or it could be talking about this bit here. So this could be your -2 here, and your -1 could be, I don't know, it could be somewhere in here, -1, or it could be, this could be here your -2, and this here somewhere in between is your -1. So it could be talking about this bit, or it could be talking about this bit here. Okay, well, try and understand the situation before you jump in and just tackle the problem. Anyway, show that this here only has 1, 0 in this interval here. So press pause and have a go. Okay, so to do this here, your gut feeling should be telling you to look at the derivative of this. When you look at the derivative of this, it could be telling you that the graph is always climbing, or it could always be falling. So let's look at the derivative of this. So differentiate this, it will give you this. Okay, if you differentiate it, what f prime will be this. Sketch this graph and it will look something like this. Okay, now in this interval here, so in this interval, put -2 into here. That will then blah 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 give you -29. So the derivative at -2 is -29. If you put -1 into here, then the gradient at -1 will be -1, meaning that, well, if you look, well, in this interval here, let's say -2 here and -1 here. You see, when x is -1, this here will be -1, and when x is -2, this is all the way down here, -29, somewhere down here. So you can see that in this interval here, the gradient is always in the negative realm. The gradient is always in the negative realm. Well, if the gradient is always in the negative realm, then that would imply, if this thing here is always in the negative realm in this interval here, then it would imply that the original function must always be falling, because the gradient is always negative within the region that we're talking about. So, hang on. So, looking at this here, we know that we know that the derivative, we know that the derivative here is always negative. That could only mean the original function must be falling all the time. It must be, the original function must be falling all the time. So, hang on. So f prime here, we know is always in the negative realm. That would imply the original function would always be falling. So, hang on. Looking at the original function now, if you put this into the original function, blah 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 blah, it will give you positive 11. So what that means is -2 here. If you put -2 into here, it will give you 11 somewhere at. Remember, we are talking about the original function. Now put -1 into the original function. So put -1 into this thing here, and then blah blah, it will be this. So look, remember, we are talking about the original function. When x is -1 here, f of -1 will be -1. Remember, we are talking about the original function, and we also know that because the derivative is negative, that implies the original function is always falling. Well, if the original function is always falling, then it could only cross over once, because it cannot do this. If the derivative is always negative, it cannot do this. You see, this here would give you three solutions, 3 zeros. But the thing is, you can see the gradient here is positive. well, the gradient cannot. If the gradient can only be negative, then it can only be going downhill all the time. It cannot do this. -2, -1. The original function, you've got 1 point here and 1 point down here. You cannot do well. If you're always going downhill, then you can only cross over once. The only time that's, well, you cannot do this, because here you've got a positive gradient. Okay, so there we've, well, yeah, okay, so yeah.